Hello teacher. Today I would like to present you about my project, which is talking about cell heating bag. Firstly, we need to know what is cell heating bag. Cell heating bags is a bag that comes with ability to heat up our foods without external heating sources of power. Cell heating bag typically made of chemical that be able to react with water and to produce exothermic reaction and release heat. When do we use cell heating bag? Cell heating bag is useful when we are away from home for any activity such as camping, long drive, outdoor excursion, and we need heating sources to cook our meal. The easiest way is to use cell heating bag because cell heating bags are lightweight, flameless, and need only water to generate heat. The process we need to do is just put the cell heating bag in the container and pour the water over them. The cell heating bag releases heat to warm our pre-cooked meal to about 100 degrees Celsius within 10 minutes. In 1990, cell heating bag was generally used for military operations, but since we see the conveniences of cell heating bags, that is safety and convenience, it began to use until today. For the material we use is calcium oxide, which is contained in cell heating bag, covered by the thin fabrics, and water we use to react with calcium oxide to produce exothermic reactions. And now let's talk about exothermic reactions. What is exothermic reactions? An exothermic reaction is a reaction which overall standard enthalpy is negative. The exothermic reaction usually releases heat to the outside and entails the replacement of weak bond with a stronger one. And how does it work? For cell heating bag, firstly we need to place it in the heating chamber unit and pour the water over them. In a very few seconds after pouring the water over them, the thin fabric that covers the heating agent allowing the water molecule to mix up with the heating agents inside the cell heating bag, which is calcium oxide. And the combination of water and calcium oxide begins and releases heat. When water molecules are added to calcium oxide, it causes some changes to the structure of calcium oxide, and it wants to be even more stable conditions. Eventually, it forms calcium hydroxide. The heat radiates when the bond is formed in the combination of calcium oxide and water. The large amount of heat generated inside the bag is sufficient to bring the mixture to its boiling point. That's how we heat up our food on the top chamber. We found out that 75 ml of water gave the best result. Here is the chemical equation. Calcium oxide reacts with water to produce exothermic reactions, form calcium hydroxide, and release heat. Here is the change enthalpy of the equation. It is negative. It indicates that the reaction is an exothermic reaction. We can calculate the change in enthalpy for the reactions by adding up all the standard heat of formation of the product and then subtracting the standard heats of formation of the reactants, multiplying each value by its coefficient in the balance equation. For the conclusions, what we have known about is an exothermic reaction that produces heat to warm our meal. And then the exothermic reactions is very useful when we are in a situation that we cannot access to the fire, like when there are natural disaster, we cannot access the fire. We can use cell heating bag to save life. Besides calcium oxide, there are a lot more heating reactions that be able to react with water and produce exothermic reactions. But some of those produce toxic gas that is harmful to the consumer. And some of them use expensive materials that cost a lot of money that we cannot afford. On the other hand, calcium oxide is cheap eco-friendly, and even completely recyclable. This feature make calcium oxide be a suitable heating source. That's all for my presentation. Thank you for your listening.